Hello! We will discuss about the tuning process of the autogas installation with the gas injection control algorithm, TEC. Please connect the diagnostic interface into your computer and start with your vehicle on petrol. Turn on the LPG TEC gas setting. You can see the connecting process in the middle of the gas setting software window. The port searching and connection of the controller to your computer will start automatically. When connected, the petrol gas switch will appear on the computer as well as the parameter setting window. Now we'll go to auto calibration overlap. The auto calibration should be performed with hot engine. In fact, the auto calibration process will start the temperature of 50 degrees. However, the closer it is to the nominal engine temperature of 90 degrees, the better. Press the star auto calibration button. Additional window will allow verification of your basis settings and turn on the additional options. Now we check the engine RPMs, so the shown RPMs match the actual RPMs according to the set number of cylinders per coil. You can stabilize the RPMs by regulating the RPM level. Choose the engine type. Set the number of cylinders. Check the found injection type. Here you can change the petrol injection times manually. Mostly we leave it as sequential. The control algorithm. The settings show TEC. Choose the fuel type. Choose the injectors type installed in the vehicle. The correct gas temperature and pressure readout will be available after auto calibration process has finished successfully. Settings check. It is an automatic verification of set parameters. The connection test is the verification of the cylinder connection sequence. Attention! Auto calibration assures that correct controller settings and performance only at idle. All injectors at once. It is the way injectors will be turned on its full group engine. No manifold pressure control should be set in cars without throttle. If you are sure that the settings and connections are correct, you can turn off the additional options. As per instructions, your vehicle should remain on idle and all functions impacting the engine load such as heating or air conditioning should be off. Press Start Auto Calibration. Now the controller will adjust the gas injection so that the petrol injection times while your vehicle is fueled by gas are unchanged from the petrol injection times while your vehicle is fueled by petrol. After auto calibration is finished, the information window will appear with the results. You can finish the calibration process by pressing Close. We also have an option to correct auto calibration parameters by the slider available after calibration. Check petrol injection times, about 3 and 2 milliseconds. Turn LPG on. The LPG injection times appear. It is advisable to check if the lambda is working continuously during the petrol gas switchover. If after switching to gas the lambda readout stays up, the fuel mixture is too rich. It is then possible to correct it by moving the slider downward. If the lambda readout stays down, the fuel mixture is too lean. It is then possible to correct it by moving the slider upward. If your calibration is done correctly, the lambda readout will be shown in fluent waving motion. Please check. Switch to petrol. The signal from lambda sensor is waving. Switch back to gas. The lambda is working stably. Everything is correct. If petrol injection times has not changed after switching to gas, you can finish auto calibration. Now we go to the MAP overlap. The information in this overlap tells us that we need to collect maps for both fuels. Your driving at the beginning should not be too aggressive. At first, you should set as many engine load areas as possible at about 2000 RPMs. When you get to about 100% engine load, you should slowly increase the RPMs and observe the subsequent injection times. After the basis petrol map is collected, you should switch to the gas. Having the diagrams of petrol and gas on, you will see the timing differences. Simultaneously, those differences will appear on the vertical diagram. While driving, first we collect the map at the whole range of RPM at about between 2 and 5,000 RPM. And then we turn our attention to RPMs and collect the map at full power. Now we will take a look to the collected map. As we can see in the diagram, we have a basis range of injection timing in optimal engine load and RPMs. This range is enough to quickly adjust gas installation because, as you can see on the fuel injection indicator diagram, we have a full range of injection times. In this example, the indicators are close to 0, so the mixture slider should be left at 1. The nozzles we used in injector rail are 0.5 mm. It is smaller than the nominal size. After a few meters you can see that are deflections towards the lean mixture. As we can see, the differences in fuel injection quickly exceeds on 1 millisecond. With these settings, it is pointless to continue driving. You should correct the fuel mixture by moving the slider. We consider the biggest indication deflections on the bar chart. We have 1.1 and 1.5 milliseconds. These numbers are divided by the value of the injection time, which corresponds to the deflection. There is 12 milliseconds. Both numbers define a range of values in which we can increase the multiplier slider. Here between 0 and 0.9 and 0 and 12. So in this case we can raise the slider to the level of 1 and 0.9 and 1 and 12. Let's lift it at the level of 1 and 12. Click on the slider and press the arrow up button on the computer keyboard. Move the slider up and reaching the gas mixture. The new value will show under the slider. Delete the gas map so that previously collected map will not be corrected, but the new values are recorded. Now we need to drive and collect the new gas map. As we see by the corrections, the differences between gas and petrol maps are in the acceptable level. That is, they do not exceed ±0.5 milliseconds. Let's see how the maps will behave when we use nozzles 0.5 mm bigger than the nominal size. As we can see, the injection times in the diagram and the sliders immediately show rich mixture. Because we have the deflection towards rich mixture, we move the slider downwards to make the mixture leaner. We calculated the range of units for the correction factor. For deviations of 1.5 milliseconds and 8 milliseconds, the injection time 8 milliseconds. For deviations of 1.5 milliseconds and 12 milliseconds injection time, the slider can be reduced by 12 and 18 units. We move the slider to the average value of the range, which is 15. Click on the slider and then with mouse pointer or down arrow on your keyboard, move it to 0.85 level, leaning this way gas mixture. The new value will show under the slider. Erase gas map. Now we need to drive and collect the gas map again. In effect, the diagram again does not overreach the value of ±0.5 milliseconds. Turn on the chart view. Please check the injection timing differences at the point where the petrol map and the gas map overlap. The digital values of the deflection at the level of 0.1 and 0.3 milliseconds assure the effectiveness of corrections applied by the slider. Please note that the optimal range of slider settings is marked by green. If we have the situation when the slider is moved beyond the green area, then the enriched mixture with small nozzles diameter will prolong gas injection times, which will cause the system to looping the gas injection. This will cause the warning, multiplier too high. Use the nozzles with larger diameter. In the case lean mixture, when slider is beyond green area with too large diameter nozzles, results is less precise regulation of installation and in effect higher gas usage. This will cause the warning, multiplier too low. Use the nozzles with smaller diameter. The optional slider setting for the properly set installation is in the middle, meaning value 1, which will also mean the correct choice of nozzle's diameter. Please view our other instructional films with detailed information about the LPG tank installation settings. Thank you for your attention.